Picture the most beautiful, pristine landscapes in North America. Vast national parks, deep canyons, steaming hot springs. They are monuments to nature's power, but beneath the surface of this tranquil beauty lies a secret, a handful of colossal, slumbering giants. We call them supervolcanoes, not the cone-shaped mountains we know, but vast, almost invisible depressions, calderas that mark the sites of the most cataclysmic eruptions Earth has ever seen. These are not just volcanoes. They are planetary forces capable of rewriting geography and climate. And America is home to some of the world's most famous and most feared supervolcanoes. The very term supervolcano sounds like science fiction, but it's a geological reality. What elevates a volcano to super status? It's a measure of pure, devastating volume. A volcano is classified as a supervolcano if it has, at some point, unleashed an eruption that ranks an 8 on the Volcanic Explosivity Index, or VEI. This means ejecting more than 1,000 cubic kilometers of material, a volume that's almost unimaginable. To put that into perspective, the 1980 eruption of Mount St. Helens, a major event that blanketed parts of the Pacific Northwest in ash, was a VEI 5. A supereruption is thousands of times larger. We begin where the modern fear of these giants was born, Yellowstone National Park. For over 2 million years, this American icon has been the site of 3 massive eruptions. The last one, 640,000 years ago, carved out a caldera 45 miles wide. Imagine the ground rising, not by inches but by feet. For months, the park's famous geysers stop. The ground becomes too hot to touch. Then, the silence is broken by a sound heard across the continent. The eruption doesn't happen at a single peak. The entire ground collapses. A column of ash and rock screams into the stratosphere, reaching heights of 30 miles. In the first hour, everything within a 60-mile radius is erased by pyroclastic flows, clouds of gas and ash moving at 400 miles per hour, heated to 1,000 degrees. But Yellowstone is only the beginning of our story. While the American West is buried under feet of gray, glass-like ash, the rest of the world is about to realize that the threat is global. Yellowstone gets the headlines, but it is not alone. To understand the true risk, we must look at the world tour of sleeping giants. 74,000 years ago, a monster awoke in Sumatra. Lake Toba. This was the largest volcanic eruption in the last 25 million years. A VEI 8 event that ejected 2,800 cubic kilometers of material. To put that in perspective, Mount St. Helens was a firecracker. Toba was a nuclear arsenal. It didn't just kill the local flora, it created a genetic bottleneck for humanity. Scientists believe the human population may have plummeted to just a few thousand individuals globally. If Toba erupted today, the 2 billion people living in Southeast Asia would face an immediate, existential threat to their water and food supplies. Now, move west to the Mediterranean. Beneath the Bay of Naples lies Campi Flegrei, the burning fields. Unlike the towering Vesuvius nearby, Campi Flegrei is a flat, sprawling caldera hidden under a city of 1 million people. It is currently restless. The ground is rising in a process called bradyseism. A supereruption here would not only bury Naples, it would inject enough sulfur into the atmosphere to shut down European agriculture for years. In Japan, the Era caldera sits at the southern tip of Kyushu. Over 110 million people live in areas that would be covered by thick ash if this giant woke up. Japan's high-tech infrastructure, its bullet trains, its semiconductor factories, its dense power grids, is uniquely vulnerable to the abrasive, conductive nature of volcanic ash. In Argentina, high in Andes sits Cerro Galán. Discovered only via satellite in the 1970s, its 2.1 million-year-old eruption was so vast it covered 100 kilometers in every direction with an outflow sheet of rock 200 meters thick. In the thin air of the Andes, the ash from such an event would circle the southern hemisphere in days, strangling the economies of South America and Australia. We often think of volcanic eruptions as primitive disasters, mud and fire. But in the 21st century, the greatest threat is to our most advanced technology. Volcanic ash is not like wood ash. It is pulverized rock and volcanic glass. It is hard, abrasive, and critically, it conducts electricity when moist. Within 48 hours of a supereruption, global aviation ceases. Jet engines, which operate at temperatures higher than the melting point of volcanic glass, turn the ash into a ceramic glaze, choking the turbines and causing instant engine failure. But the silent killer happens on the ground. Power lines rely on insulators to keep high-voltage electricity from jumping to the support towers. A mere 5 millimeters of ash, combined with a light mist or rain, creates a flashover. Transformers explode across the continent. Repairing a grid covered in toxic, abrasive dust is a task that could take years, not weeks. Our modern world lives in the cloud, but the cloud is actually made of massive server farms that require constant, clean air cooling. Volcanic ash is fine enough to bypass many industrial filters. It jams cooling fans and short-circuit circuit boards. In a matter of days, the internet as we know it, banking, communication, logistics, begins to flicker out as the ash settles. A more terrifying phase begins, the volcanic winter. The eruption has injected millions of tons of sulfur dioxide into the stratosphere. This gas reacts with water vapor to form sulfuric acid aerosols. These tiny droplets act like a billion microscopic mirrors, reflecting sunlight back into space. Global temperatures would drop by 3 to 5 degrees Celsius, 5.4 to 9 degrees Fahrenheit, for a decade. This sounds small, but it is the difference between a harvest and a famine. In the American Midwest, the breadbasket of the world, the growing season would vanish. In Southeast Asia, the monsoons would fail as the thermal balance of the ocean shifts. The economic chain reaction. With no power, no internet, and no food, the global economy enters a dark age scenario. Money loses its digital meaning. Trade routes through the ash-clogged skies and seas are abandoned. Nations would be forced into radical isolationism, hoarding what few resources remain. It is easy to look at these giants and feel a sense of doom. But humanity is a species defined by its resilience. We survived Toba 74,000 years ago with nothing but stone tools and campfire stories. Today, we have the advantage of foresight. Across the globe, from a Yellowstone volcano observatory to the monitoring stations at Campi Flegrei, scientists are listening. They use satellites to measure ground deformation, seismometers to track the movement of magma, and chemical sensors to smell the breath of the giants. If we have a year of warning, or even a decade, we can prepare. We can harden our power grids, develop ash-resistant air filters, and stockpile the seeds of our future. The supervolcanoes remind us of our place. We do not own this planet. We are its guests, living on a thin crust above a churning, fiery sea. Our survival depends not on our ability to stop the Earth from moving, but on our ability to move with it. The giants are sleeping. For now, and in the silence of their slumber, we must do the work of building a world that can withstand the day they finally wake up.